In MCQ number 5, this is a chemical bonding question, and we are tasked to find out of which of this 1, 2, 3, and 4 actually any of the species actually contains a total of 2 pi bonds. So just a very quick summary in terms of the allocation of pi bonds as well as sigma bond. For the case of A level, if we're looking for just a single covalent bond, we're looking at a net tally of 1 sigma bond. But moving towards a double bonded structure, there will be a total of 1 sigma bond together with 1 pi bond, and at the last instant of a triple covalently bonded diatomic compound, we're looking only at 1 sigma bond but a grand total of 2 pi bonds. Right, that kind of indicates to you that sigma bond is ever present, but from single and triple bond onwards, you are starting to see the manifestation of a pi bond. So, as per usual, let's just draw out the Vesper structure. Al2Cl6 is a very popular chemical bonding structure because it exists as a dimer. It's actually better if you see them as your AlCl3 times 2. The reason here is because your aluminum that is found in aluminum trichloride exists as a Lewis acid, and that means that it's actually looking to be a lone pair acceptor. That's because this particular aluminum in this diagram only has a total of 6 valence electrons. It would appreciate 2 more extra electrons in the form of a lone pair to achieve an octet configuration. So for the case of number 1, I'm looking for aluminum. Initially is existing as a trigonal planar structure. I'm just going to draw another adjacent aluminum trichloride over here. And the aluminum for each of this AlCl3 monomer exists as a Lewis base, acting as a lone pair donor. And in this case here, we're looking at a form of dative bonding to assist the adjacent aluminum in achieving your octet configuration. Now, unfortunately, for number 1, you can see that they are all single bond, and since they're all single bond, it is just purely your sigma bond that you are actually looking over here. So option number 1 is out by itself. I will not be selecting option B over here. Now take a look at number 2. We're looking for carbon dioxide. This is a linear configuration. Easy to see over here that since this is a double bond, I have 1 pi bond over here. I have another 1 pi bond over here, very similar to what I've actually mentioned here. So number 2 definitely is a contender because there's a net total of 2 pi bond. Take a look at option number 3. This itself is actually an aldehyde, particularly ethanol. So CH3, CHO. Now based off this, we're definitely looking at a C double bond O. We have a 1 pi bond over here. Now unfortunately, there's only a total of 1 pi bond. Now in the last option, number 4 over here, we're going to have a CH2 followed by a CH and followed by a CH3. This itself is actually your propene, and again you see another of your double bond, C double bond C. We have another 1 pi bond over here, and because of particularly what the question wanted to have 2 pi bonds, I'm then obliged to say that only C is going to be the correct answer, because 2 only in structure number 2, carbon dioxide, this is where you see a grand total of 2 pi bonds.